Hi Year 12, welcome back. This is term 6, we're on the home straight of this year. There's two topics to cover this term that I want to go through, and the first is functions and graphs. Okay, chapter 2, these two topics we're going to do are from next year, just to give us a bit of a head start. So functions and graphs, the first piece that I want to have a look at is this new notation which is called the modulus function. Okay, and I think a lot of you have seen this before, but in case not, we've got this new notation. These bars is the modulus of a number, sometimes called the absolute value. And if you want it on your calculator, I believe it's the abs button, or you've got a button that looks like that with the bars. What it does is it takes a number and it tells you its non-negative numerical value. Okay. Another way to think about it is this is its size or its magnitude. Okay. If you spot this notation in other topics like vectors, you'll notice that they're very much linked. Okay, it's to do with how big or what the size is. So as some examples, the modulus of 6 is just 6. And the modulus of a negative number, minus 7.1, is the positive version of that number. Okay, so you might want to think of it as these bars throw away minus signs, after this thing has been evaluated. All right, it's quite useful in expressing a difference. So if you want to know how far apart two numbers are, b and a, using 4 and 7 for this example, then you can do b minus a, but that's minus 3. That's not really the distance between them. To get a distance, you use the modulus. So this absolute value of b minus a, that just tells you how far apart these two numbers are. All right. As a little aside, what we're going to do, I've explained what it does, but what we'll do is we'll kind of define it properly, and I'll write down how we normally see this function kind of defined explicitly as a function. So as an aside, okay, not necessarily need to know this, but it's worth writing it down. So this is what the modulus function does. The modulus of x is, well, normally you'd see this split into two cases, all right? So if x is positive, then it's just x, okay? It leaves it alone. So x, if x is bigger than or equal to 0, okay? 0, it leaves that alone, it'll just be 0. Anything positive, it keeps it as itself. But the interesting case is if this is a negative in here, then it will make it negative again to make it positive. Okay, so minus x, which is a positive number, if x is less than 0. Okay, so you quite often see this as the definition of the absolute value. It's not especially needed for A-level, but it's worth having that in the back of your mind as to what it does. There's two other ways to write this down in a more compact form, which you might be interested in. Okay, so there's a closed form of this, function here, and that's to say that modulus of x is, and to get to one of these, well, these are the same value, but to get to this positive value, you can do the square root of x squared. Okay, so the x squared in the middle makes it positive no matter what, and then the square root takes the positive square root. So you'll either end up back where you started, or you've made your negative number positive at the end. Okay, so that's one way. The third way is you can say, okay, so you take a look at two numbers, which is going to be x and minus x, and then just say which one is the biggest. All right, so out of these two, you pick the positive one, basically. All right, so that's the most usual way, and these two kind of optional extras. Okay, right, what you need to be able to do with this is mostly be able to plot a graph that has a modulus symbol in it, and then use it to solve an equation. So I'm going to show you how to do that. This is following good old Dr. Frost. Before we do that, I'm just going to, we'll see what happens when we sub numbers in. It's not too difficult. Maybe just do one or two of these. So if this is f of x with this plus 1 on the end, we can do f of 5. 5 goes in, and then you've got 10 minus 3 in there, that's 7. The modulus of 7 is itself. You add 1 and that's 8. Okay, nice and easy. Put in minus 2. 2 minus 2 is minus 3. Work that out, that's minus 7 this time. The modulus of minus 7 is positive 7. Add 1, that's 8. And something similar for the third one. Okay, so just nice and easy just to plug some numbers in. Right, here's the important bit. The graph of a modulus. I'm going to get rid of that. This is the bog standard graph, okay, of a modulus graph, just absolute value of x, or mod of x for short. So what this is going to do, if it's negative, it's going to throw away that minus sign, so minus 2 becomes 2, minus 1 becomes 1, and then non-negative numbers get left alone, so it's just going to be 0, 0, 1, 1, 2, 2. plot them, and this is your modulus graph, okay, the basic one. It's a V shape. What you're typically going to get is you're going to get graphs that aren't allowed to go below the x-axis, okay? Things get reflected from below the x-axis where outputs are negative to above the x-axis where outputs are positive, okay? That's the basic graph. And it's saying there, just as a generalization, if you've got any linear graph and then you mod it, best thing to do is sketch the graph on its own without the mod bars on it, and then anything below the x-axis just reflect it up. Okay, and we're going to see an example on the next slide. Okay, so here we are. So I want to sketch this. Sketch y equals the mod of 2x minus 3. You'd want to sketch bog standard 2x minus 3, which is going to be this portion. Okay. And then any negative outputs will be reflected up to positive outputs. Okay, we've sketched this graph with y-intercept of minus 3, x-intercept of 3 over 2. If you set that equal to 0, then when you reflect, that minus 3 is going to jump up to 3. Okay, let's just double check what goes where. And then the non-dotted bit, the solid lines, is the graph of what you want. Okay. Then once you've done that, you might be asked to solve an equation. It would be like a hence question. So now you've got the sketch to solve this equal to 5. I think a sketch is going to be the most useful thing for you to do because it tells you how many solutions you're likely to get. All right. If I plot y equals 5, which is this right-hand side, it looks as if I'm bound to get 2 solutions here and here. So yeah, it gives you a good idea of what's going to happen when you get your answers out. Then the algebraic thing to do is to split this into 2 possible cases. Okay, this modulus function here has got 2 kind of parts glued together on it. Okay, the one part is just itself, the 2x minus 3. Okay, that's going to be this piece on the right, and the other piece is going to be the negative of that piece. The bit that we've reflected upwards is minus bracket 2x minus 3, which on the slide it distributes the minus and makes it 3 minus 2x. Okay, and that's going to be this piece over here. That's the bit that got reflected, but that chunk on its own is a portion of the graph 3 minus 2x. Okay, so what you do is you take these separately and you solve them equal to 5 separately, and then you get 2 potential answers. So there's the unreflected piece. The 2x minus 3 is 5, x is 4. On the reflected path, the negated part, there it is, equaling 5, and x is minus 1. Now, what it's important that you do is you take your solutions, and I would urge you to always sub in to the original equation. Okay, there's lots of scenarios where if you don't draw this picture, you might be fooled into getting a potential solution that doesn't actually work. Okay, so I'm going to say sub in, even though it's clear from the picture these are going to be valid. I still want you to be able to do that. So let's put in x equals 4. So you get mod of 2 4s are 8, minus 3, that's the modulus of 5, which is 5. So that one's good. For minus 1, you sub that in. So 2 minus 1 is minus 2, minus 3, that's minus 5. Take the modulus, and it becomes 5. Okay, so we're good for those, okay? But just be aware that there are lots of times where your answer isn't actually valid. For example, if I change this number to a negative, if I make it minus 2, then you could draw your minus 2 down here. It's going to be above the minus 3, isn't it? It's going to be something like that. Okay, and what it's going to do is it's going to give you a solution that wants to go there, but that's not part of the graph that you've got because it's the dotted part, okay, the bit that we've got rid of. Okay, so just be careful. All right, a couple more examples. Solve this function equals this one. You'd want to carefully plot the modulus graph. Okay, that's the V shape. Carefully sketch your 2 minus half x, something that seems kind of reasonable shaped, 2, downward gradient, that kind of thing. Then again, we've got 2 potential solutions. We've got this one, which is going to be to do with this part here, because that's the positive version of this graph here, the linear one. And then we've got this one as well, corresponding to this bit, which is the negative version of this graph, okay, 5 minus 3x instead. Get your solutions, sub them in, okay, just check that they both work, and you're good to go. Okay, one more. If there's an inequality, then it's very, very similar. This is where the sketches are really going to help you out because it tells you where one graph is bigger than the other or smaller than the other. But we've already got the sketch. We want to know where the modulus graph is beating the other linear graph. And from the picture, it looks as if that's on this particular portion. Okay, that means we're above that part there and this part as well. Okay, again, that part is bigger than this part. And we found the intersection points, 6/5 and 2. The x values for where we're in the pink is bigger than 2 or less than 6/5. Oh, so it looks as if this is wrong. Okay, it's actually not that. It's x is bigger than 2. Let's do it with a better pen. Or x is less than 6/5. Okay, so yeah, again, sketch is important and make sure you're looking at the right pieces. Right. These are two other examples. I don't particularly want to go through them, but you can if you want to have a look just to see that it's the same method and then it all kind of works. Again, I would stress check the solutions once you've got them. Okay, if it says if you get to x is -2, plug it in, make sure it works. Same for this one, check them both. And it's another inequality, and it's this. I think this is wrong as well, isn't it? If that v shape needs to be below 2x, you're in between. So I think that needs sorting out, but I think you can kind of get to grips with it. Okay, that's the modulus functions. Okay, that's for exercise 2A to start off the next part of the course. All right, thanks year 12. I hope you settle back into year to term 6, and I'll see some of you in class shortly.